For 30 years, Neptune has been one of the most mysterious planets in our solar system, a distant frozen blue world shrouded in darkness since Voyager 2's flyby in 1989. But the James Webb Space Telescope has finally given us the most detailed, highest-resolution images of Neptune in 3 decades. What these images reveal is not just beautiful, it is deeply unsettling. Something strange is happening on this ice giant. Features that should not be there. Behavior that defies our understanding. A mystery that has left astronomers whispering, "We thought we knew this planet." This is Galactic Origins, and over the next several minutes, we will examine the new images, the unsettling anomalies they show, what scientists are saying, and what this means for our understanding of ice giants and the outer solar system. The new JWST images, just released, are nothing short of breathtaking. Using its powerful near-infrared camera, the telescope has captured Neptune's faint, dusty rings with unprecedented clarity. The best view since Voyager 2 in 1989. But it is not just the rings that are shocking. The images also reveal unexpected atmospheric features, mysterious dark spots that appear and disappear, and auroral activity that challenges existing models of how ice giants work. One leading planetary scientist described the data as both beautiful and deeply puzzling. The rings are the most striking feature. Voyager 2 saw them as faint, dusty bands. JWST has now revealed them in sharp detail, multiple distinct rings with complex structure, some appearing brighter and more dynamic than expected. Even more unsettling are the transient dark spots and unexpected cloud formations in Neptune's atmosphere. In research labs, these images have sparked intense debate. Neptune was long considered a relatively calm ice giant compared to Jupiter and Saturn. The new JWST data suggests otherwise. The atmosphere shows surprising variability, with storm systems and dark vortices that evolve rapidly. Some features appear to defy the extreme cold and low energy input from the distant sun. This has led some researchers to question our fundamental understanding of ice giant atmospheres and internal heat sources. Is there an unknown engine driving this weather from deep within? The mystery deepens when we consider that Uranus, Neptune's twin, appears much calmer in comparison. Why is Neptune so much more dynamic? This is one of the biggest unanswered questions. After 30 years of relative silence, JWST has reopened the book on Neptune, and what it is showing us is far stranger than anyone anticipated. The most visually striking revelation from the 2026 JWST images is the incredible detail in Neptune's ring system. Voyager 2 in 1989 saw faint, dusty rings that were barely detectable. JWST's infrared vision has now revealed them with stunning clarity. Multiple distinct rings with complex structure, varying brightness, and unexpected density variations. Some segments of the rings appear significantly brighter than models predicted, suggesting recent activity or replenishment of material. This points to a much more active system than we ever imagined. In research labs, these ring images have sparked intense discussion. The rings are not static relics. They show signs of dynamic processes, possible collisions, moonlet disruptions, or gravitational interactions. One 2026 research paper notes, "The complexity and brightness variations in Neptune's rings suggest ongoing dynamical activity far greater than previously assumed for an ice giant at this distance from the Sun." Even more unsettling are the changes in Neptune's atmosphere. The new images reveal transient dark spots and vortices that appear and disappear on relatively short timescales. Bright methane clouds and storm systems are more active than expected. The planet's weather appears far more dynamic and energetic than models predicted for such a cold, distant world. This raises fundamental questions about the internal heat source driving Neptune's atmosphere. Does the planet have a stronger internal energy reservoir than we thought? These observations challenge our understanding of how ice giants generate and transport internal heat, and how their atmospheres respond to extremely low solar input. Some researchers are calling for a complete reevaluation of ice giant atmospheric physics. After 30 years of relative silence, Neptune has suddenly become one of the most intriguing and unsettling planets in our solar system again. The new JWST images have reopened old questions, and raised entirely new ones. One of the most unsettling features in the new JWST images is the presence of large transient dark spots in Neptune's atmosphere. These dark vortices appear and disappear on timescales of months to years. The energy required to sustain these features seems higher than what Neptune should receive from solar heating alone. This points to a powerful internal heat source deep within the planet. In research labs, these storms have sparked debate. The mystery deepens when we consider that Uranus, Neptune's twin, appears much calmer in comparison. Why is Neptune so much more dynamic? The images also raise new questions about Neptune's ring system maintenance. Something must be continuously supplying material to them, possibly collisions or dust from moons like Triton. Let us explore a thought experiment. Deep inside Neptune, enormous pressures and temperatures create conditions unlike anything on Earth. Residual heat from the planet's formation generates a powerful internal energy flux. This heat rises through the icy mantle in massive convection cells, eventually breaking through the atmosphere as powerful storms and dark vortices. The new JWST images suggest this internal engine is more active than we assumed. Neptune is not a cold, dead world slowly freezing in the outer darkness. It is a dynamic, evolving planet with its own internal weather system. The outer solar system is full of surprises. They remind us that even planets we thought we knew reasonably well after Voyager 2 can still hold profound mysteries. The outer solar system is not a quiet, frozen realm. It is active and dynamic. The unsettling new images of Neptune have implications that extend far beyond this single planet. They are forcing scientists to reevaluate our understanding of ice giants as a class, and by extension, how our solar system formed and evolved. Neptune and Uranus have long been considered twins, yet JWST's view shows Neptune to be significantly more dynamic and active than its neighbor. This raises questions about their divergent evolutionary paths. One leading theory suggests that both Uranus and Neptune formed closer to the Sun and were later scattered outward during a period of chaotic migration of the giant planets. During this violent phase, Neptune may have experienced more intense interactions or even a significant collision that left it with more internal heat and a more active atmosphere. The rings, storms, and atmospheric activity we see today may be lingering signatures of that early violence. The contrast with Uranus is particularly striking. Uranus appears relatively calm with a tilted axis and faint rings, while Neptune shows vigorous atmospheric activity and more prominent rings. Understanding why these two similar mass planets evolved so differently is now a major priority in planetary science. The new images suggest that internal heat flow and dynamical history play much larger roles in shaping ice giant behavior than previously appreciated. This has direct implications for our understanding of exoplanets, many of which are ice giants orbiting other stars. Let us explore a thought experiment. Imagine the early solar system 4 billion years ago. The giant planets are migrating through a dense disk of planetesimals. Gravitational interactions fling Neptune outward into the Kuiper Belt region. During this migration, it experiences close encounters and possibly a major impact. Over billions of years, this residual heat continues to drive atmospheric convection, maintaining active storms and dark vortices even today. The new JWST images may be showing us the long-term consequences of that ancient chaos, a planet that still bears the scars and energy of its violent youth. After 30 years of limited data, Neptune has re-emerged as one of the most dynamic and mysterious worlds in our solar system. The JWST images have not only given us beauty, they have given us questions. Questions about internal heat, atmospheric dynamics, ring maintenance, and the true nature of ice giants. They remind us that even in our own solar system, there are still major discoveries waiting in the darkness. The outer solar system is not a frozen graveyard. It is alive with activity, history, and unsolved mysteries. After 30 years of relative silence, Neptune has spoken again. And what it has revealed through JWST is both beautiful and profoundly unsettling. The planet we thought was a cold, quiet world has proven to be far more alive and mysterious than we imagined. This discovery marks the beginning of a new chapter in ice giant science. For decades, Neptune and Uranus were the least studied planets in our solar system. JWST has changed that overnight. The new images have reopened old questions about internal heat flow, atmospheric dynamics, and ring evolution, while raising entirely new ones. They have forced us to rethink their formation and evolutionary histories. The implications extend beyond Neptune. What we learn here will help us understand the thousands of ice giant exoplanets discovered around other stars, many of which may be even more extreme. Let us end with a thought experiment. Imagine the year 2040. A dedicated Neptune orbiter has arrived after a long journey. It maps the planet's interior, samples its atmosphere, and studies its rings up close. That future mission will owe its scientific foundation to the groundbreaking JWST images of 2026. What seems unsettling and mysterious today may become the key that unlocks our understanding. Neptune's new images remind us of a simple but powerful truth. Even in our own solar system, there are still major mysteries waiting to be solved. The outer solar system is not a frozen dead region. After 30 years, we have finally seen this distant world with new eyes, and what we see reignites our curiosity. JWST has once again shown us how much we still have to learn about the cosmic neighborhood we call home. Thank you for joining me on this long, detailed journey into Neptune's remarkable return to the spotlight. What do you find most surprising about these new images? The active rings, the dark spots, or the fact that we still know so little about our own solar system? Drop your thoughts in the comments. I read every single one. If you love these extended, deeply researched explorations into our solar system and galactic origins, please hit like, subscribe to Galactic Origins, and turn on notifications so you never miss an episode. This is Galactic Origins, uncovering the hidden wonders and mysteries of our cosmic neighborhood. Until next time, keep looking up with curiosity and wonder. Neptune's mystery is just beginning. Stay tuned for more cosmic discoveries on Galactic Origins.